Welcome to ClickMyProject.com. Now we discuss about the product for dual band on body repeater antenna for in and on WBAN applications. Next we see the abstract for the product. Owing to their variety of potential medical applications, wireless body area networks have received much attention. Medical implants for treatment, diagnostics and monitoring has been studied in conjunction with the WBAN. For example, the biomedical self-monitoring system for implanted devices can be designed using the WBAN concept. For WBAN communication, the transmitter and the receiver can be located in three regions: in-body, on-body and off-body. However, the antenna is implemented devices usually have extremely low radiation efficiency because of the body effect. Therefore, they establish the direct communication link between the implanted antenna and antenna for on-body self-monitoring is difficult. To communicate effectively, the signal must be collected from the implanted devices and transmitted to the on-body self-monitoring devices using repeater systems. The dual band on-body repeater antenna for in and on wireless body area networks applications is proposed. The proposed antenna has a maximum radiation normal to the human body surface for the communication with implanted devices in the 5.8 GHz industrial, scientific and the model ISM band. In addition to transmit the biological information received from the implanted devices to other on-body devices, the proposed antenna was designed to have the monopole-like radiation pattern along the surface of the human body for communication in the 2.4 GHz ISM bands. The antenna was fabricated and its performance was measured by attention to the human equivalent semi-soiled platform. In addition to the human body effect was studied to ensure the antenna performance under the actual situation. Next we see the flow diagram for the antenna design. We implement the antenna design using the HFSS software. This software to implement the high frequency synthesis simulator based frequency development and the bandwidth calculation to be all the designs and developments to be included in the HFSS software. So first we open the new HFSS software and new project design in our 3D model based designs. Then create a new project design. Then go to first we create the any one of the antenna. First we choose the substrate model, and to analyze the substrate model and the dielectric constant value and permittivity value and the dielectric substrate modeling type, all the things to be noted. Then we select and create the patterns for and the shapes for our substrate model, because example for circular or rectangular or square or triangular based substrate model used in our any one of the HFSS modeling designs. Then we apply the which substrate model to be implemented, example for Roger 54003 or 5005. So then to apply the substrate model, then we go to the assign substrate material type. The material is represents the same like a Roger material, and we go to the patch model design. Whatever patch model we use, the circular, square or rectangular patch model to be implemented in our designs, and we using the polyplane for rectangular shape cut, all the things, and we add and subtract the implement design, and to connect the what are the patch model implement in our secured diagonal patterns, and we implement the XYZ dimension based substrate model design in our secured selected new project. Then we go to the to design the bottom patch and top patch design. Every model consists of the ground plane and the top plane structure for our required patch wise designs. When the substrate to be included and the multiple substrate model and the 3-layer model and all the things to be designed in the first design based process. In every antenna design, we implement first the design phase completions process to be calculated. Then we go to the final design phase process. After design process to be completed, then we go to the analyze setup work for every antenna design. The analyze setup mainly focused by the boundary wise designs and the excitation wise designs in our field setup. Whenever you use the electrical field and we use the waveport model, and the magnetic field we use the step up port model for overall antenna designs. These designs to be applied for the frequency range. Then to set the frequency for a start and stop frequency and the solution frequency. The solution frequency to be changed based on the antenna model designs, and whatever we working the full bandwidth and to coverage with the center frequency range for our required solution frequency model. Then to set up all the frequency model and to run and the overall process. Then if the run to calculate the S parameter, and it's like return losses for our required antenna design, then we go to the empty boundary box to be set up for our required antenna model design, and to set the radiation pattern. This radiation pattern to set the pattern wise model for our required 360 and 180 degree pi and theta value for set up for our overall radiation pattern. Then to calculate the radiation pattern graph and the polar plot graph and the gain level and all the things VSWR, each and every analysis for required antenna design to be calculated for our required model, final model. These are the final flow diagram for the antenna design process. Finally, we see the output for the product. These are the project on HFSS file. Just public the HFSS model and to open the required antenna design. Then open the design model and to process with the new project deviations. These are the overall designs, and to this is the feeder point structure, this EPG structure, these are the required antenna model design. These are the final output antenna model design for our required final process. You just simulate, then synthesis our required antenna model. Then we go to the results file and to just see the antenna model design, and to working for our 3-band structure for required our final output for the structure. These are the 3-band structure on the band separation technique. These are the final design working with our correct output procedure for our antenna model design. Then we use the BEC material structures and the lumped port and the perfect E for our required EPG structure and the ground plane and the top patch design. These are the final output for our antenna based model.